Hello and welcome to See Those Projects. Today we're going to be 3D printing microlenses on a Formlabs printer for my NASA SONTRAC senior project. I'm filming this intro after I've already done the video, just because of the fact that I want to make sure that I can actually do this. Now, these lenses are 1mm diameter lenses in an 8x8 array. What these are meant for is to focus incoming light from fibers into silicon photomultipliers, which will then give tracking data. I'm just designing the lenses just so there's less crosstalk between the silicon photomultipliers. Just because right now when it comes out of the fiber, the things can split and there will be multiple readings on the different silicon photomultipliers instead of it just going straight. We're doing plano-convex lenses like these, which I'll show a photo of that, because of the fact that they are a collimating lens. A collimating lens is going to funnel all that light into a single focal point instead of having it possibly diverge out. Now, I still cannot believe it. We actually got these things to look pretty good, but I don't want to spoil too much. So we're going to be using a Formlabs 3 printer and clear V4 resin. Not V4.1 because we only are using the old stuff that we already have. Now, the reason why we're using it is A, we don't have access to the nanoscribe currently, which is the machine that we plan to use. The Formlabs printer uses SLA for creating its, products. The nanoscribe printer, or the Photonics Professional GT, utilizes 2PP for its fabrication. 2PP is 2-photon polymerization. It takes a laser, hits a resin, and cures it, and it's light years more accurate than an SLA printer, or at least specifically a $3,000 printer. Now, a nanoscribe printer usually costs about $1 million. So I'm going from using a $20,000 to $20 million machine to a $1 million machine, which we're going to 3D print the final versions of these on, to a $3,000 machine. So, throwing up some math around and with materials cost and other expenses, if I'm able to create a semi-usable prototype, this is not going to be a final prototype in the slightest, or a final product, I will be saving almost 30,000% more money. So this will cost 30,000% less. So I'm very happy to say that. But right now, this is just a test to see if I should use a thick base or a thin base, and if I can actually create a lens without scratching it. So we're gonna get to the part where I actually started to make the lenses. Now that we have the stuff done, we're gonna pop them out, and we're gonna get them ready to be cured. So you can see they came out pretty well, and as you can see, there's also no weakening. It's actually, it's still straight, which is the reason why I placed the support in that specific way. So you have to be safe to not damage the lenses or even touch them. Sort of like that. So we're just gonna nicely take them and place them on the curing raft, or at least into the water, and you'll see. Now, as you can see, they are fairly clear. I mean, you could see like right through that. It's not opaque in the slightest. Well, everything is technically opaque, but there you go. So now, with that on there, I'm going to put this through the wash just to clean it off. But in the meantime, while it's washing, we're going to, one second. Okay, so in the meantime, while it's washing, we're now going to get this stuff ready. Now, we're skipping the washing station because apparently it can turn it opaque faster and will also yellow it. Now, apparently, which I've done in the past, just using water and using that to remove a bunch of the resin will actually help with the top. The only problem is, though, you have to be, again, very careful not to touch the lenses. Because if you touch the lenses, well, you sort of ruin them. And this is water that I literally just filled up not even 2 minutes ago. It almost actually looks like the, well, it did print. Okay. Well, I'm only gonna touch the lenses on here. What I'm seeing right now is that these lenses, for some reason, have a bunch of the extra resin on there, which I know, yes, would get taken off in the wash, but normally, or at least the last time I did this, it worked. So I'm only gonna end up touching the bottom of the, what is it? I think this is, okay, this is the non-thick one. This is the one with the thinnest layer, which is a 0.1 millimeter gap. So, now that we have those two dunked, we're just gonna dunk them again. Get as much water as we can off of them. And now, originally we would wait for them to dry, but I'm curious to see what would happen if we just go and we shake them off and then we use a light, well, I just touched the lens on the other one. Well, we're gonna take this lens and we're gonna blow it off using an air gun, a very thin one, just to get rid of all this extra water, because since it is such a thin surface, it should be doable. So you're gonna pop this open so this thing can start drying. I originally was going to do a much more in-depth video, but due to time constraints and the fact that people are blasting music today for some reason, I will only just do the testing, and I will actually ask my advisor which one he cares more about. Ooh, would you look at that? Right there. Hopefully it'll focus. Come on. Ooh. Right there, it started to deviate a tiny bit, and this is the... Oh, dang, this is the thick version too. Huh. Well, the best way you could deal with this is just more supports. But again, we're not going for a final product, we're just seeing, can we create refractive light? Or at least, can we actually funnel the light using these? Because if we can, that's gonna save us a lot of money. So I'm gonna go use the air dryer on this thing. Alright, so we're gonna consider that pretty dry. And now what we're going to do is we're going to take this and we're gonna shove it in the curing station. Hopefully it'll cure. I don't know if it will, because of the fact that it's still a little bit wet, but it's worth a try. See, the good thing with this is that I can just take it and print this and say, oh, well, if I mess up one little step, I can print God knows how many more. I mean, I have an entire tank of new material, which is gonna be awesome. And so the reason why we're actually doing this is because the nanoscribe machine that we want to use is very expensive, both materials-wise and actually like usage-wise. And we're only going to be able to get about 2 to 3 prints. So if we can go and test the actual refractiveness and functionality of these lenses before we make them on the nanoscribe, it'll save us so much money and so much time. So that's why we're sort of doing it. Now, I'll give a better explanation once that lens is done, and I guess I'll do an update on the channel after that lens is finished drying by hand, or just normally. So originally you're supposed to really cure this for only 2-ish minutes, and then just let it go out. The only thing is though, I want to try for 10, just so that it gets a nice, much nicer punch to it, and well, just will work. I don't know. So this is sort of just, I'm trying to get it to work, and I'm just trying different methods. So I don't know what method will make it go better, or what method will make it go worse. So, yeah. We have it done. It does not look fully cured in the slightest, but we can get it to focus in nicely. Oh yeah, you can see that perfectly. You can see how clear that is. Now here's the real test. If I shine a light and it focuses, it's gonna be really cool. So let's see. Oh yeah, look at that. Come on. So it's definitely focusing it, because when I'm not fully close to it, it does it. So this works. That's awesome. Okay, so it does work. Now, I'm gonna let this cure for a little bit longer, and then from there, I'm going to actually use a microscope, a handheld microscope that I have, and we're going to turn that into, well, we're gonna take some photos of it. Only just because of the fact that this is useless because of the bend that it has, which I'm gonna have to figure out why it did that, and if it's negatable by just, I don't know, adding a ridge along the side of it. I don't know, because this is very thin and this is supposed to be the thick version, so yeah, so we'll get some photos and we'll go to there right now. Alright, we have the stuff done, and now we have our microscope and our two lenses. We have the thin one and the thick one. So we're going to go and we're going to zoom in on here. Thankfully with the stand, I can go and maintain focus on it. And look at that. Granted, it's not perfectly cured, but come on, I can position this to get this. Come on. No. There we go. Okay, so now we focus it. And look at that. Those look nearly perfect. Granted, as you can see, on some of them, it doesn't look as good, but this single row right there looks absolutely amazing. I mean, there's obviously some amount of surface imperfections, but it's almost perfect. So that was the thick one, and now that that's the thick one, I mean, you can see that this was definitely successful. Okay, so now let's try it with the thin one and see what we get. Just gonna move it into, wow. Also, look at that. You can literally see right now how it's acting like a lens, because right there in the camera, you can see my finger right behind it, and you can see how it's actually reflecting the light, or what do you call it? It's pulling the light from, I don't know how to describe it. I'm just very happy right now, but you can actually see how it's sort of bending it. You see how it's not fully engulfing the rest, so it's actually pulling the light from around it, and oh, that's just so awesome. I'm a computer engineer. I don't know about optics too much, which is why I'm doing this project. But look at that. Obviously, there's some amount of surface imperfections, and that's because I touched the lenses by accident when I sneezed. But regardless, I mean, it looks absolutely amazing. It's not scratched. It's not perfect. These can be 100% usable. Here, let's up the brightness a little bit. But I mean, look at that. It's absolutely perfect. And with that, I mean, that sort of confirms it. And the funny thing is, this test was to see which one would be fine, if I could print a thick base or a thin base. And it looks like the thin base actually printed better. Because if you look at the thick base, here, let's just zoom out so we can get that angle. Wow. Okay, 1 second. So if you see, sorry, angling this is a little bit weird. So as you can see a little bit right there, that there's a bend in the print for the thick one. You can also see how small that hair is. But if you go and you look at the side profile of the thin one, you can even actually see a little bit of the yellowing. If you go and you look at the thin profile, I'm going to do it by hand, you can see that it is perfectly straight. Meanwhile, this one, going back to it, yeah, you have that big bend in it. So it actually looks like the thick one, which, let's see, can I get to focus on it and show you the name? The thick one right there is actually not as good as the thin one. Wow, okay, so we'll actually stick with the thin one. That's crazy. But I mean, even looking at an angle from here, yeah, let's see if I can focus a little bit on the, and this is without a wash and just water. Next time I was thinking about trying isopropyl, but for a test to see This is perfect. So I consider that fully a success. That's a success. We can print it. As you can see, the lenses actually work. They work really well. They're able to focus just a little bit of light, and as you can see by the light bending in the lenses when my finger was right next to it, you can actually see it pulling it up on the lens, which is showing that it actually works. I don't know a huge amount about optics, which is why I'm doing this project. And with this, seeing that the fingers curve, and when you take a little flashlight, it focuses it to a point, just shows that this is actually possible. I can 3D print lenses on a machine that is the actually commercially available thing, instead of having to pay thousands of dollars just for one piece for paying for a service, or buying a $10 million machine for industrial stuff, or even using a $1 million machine. I can use a $3,000 machine for prototyping, which will save me so much money, because as long as the properties of the resin, like the refractive index, are close to the materials that you plan to use in the final product, it should react the same. So you should be able to test it easily. And so being able to do this cuts down our expense cost and our time. These two took 41 minutes to make. 41. The other stuff that we plan to do could take upwards of 3 hours. Also, originally in this project, we were planning just to 3D print one lens at a time and then get to the array. At this point, since it's so easy just to print an array together and it makes it easier to remove it off the board, we're probably going to just start with the arrays. I mean, it's absolutely amazing. Now, we will design one single lens, and we will print just at least one lens just so we can do a testing for it, just because the fact that as of now, we don't know what we can and can't simulate in Code 5, which Code 5 is a software that you can simulate light optics in based on a lens, but my friend Kevin, he's going to be focusing mostly on that. And this is awesome. So, the only thing that I have next to say is, this is with a plano convex lens. Since I'm in the honors college, I have to do something a little bit extra. I'm going to now design an aspheric lens, which should help with focusing the light, and honestly should perform differently because of the fact that apparently aspherical lenses remove spherical aberration, which I don't know the full extent to that. I just know that it messes with the spectrum of light in a certain way. So what I'm going to do is I'm going to design it and test them, and I'll be able to do that really quickly because I have the printer. So we'll actually be able to test something instead of having to wait or just do something fully theoretically. Because there is a good chance, because of the amount of funding that we get for our senior projects, that we wouldn't have been able to print these. Like, we would have ran out of funds for the resin, or just the like paying someone to use the machine. So I get to actually test something non-theoretically. Well, I'm testing it in Code 5 regardless, but I actually get to test stuff like this that in the past you never would have been able to do. So I can't wait to do the aspherical lens, and I will definitely upload, even if it's just a short to the video. I will definitely upload that as an update. And it's also just awesome the fact that you can just have a microscope. I mean, obviously it's not a super accurate microscope, but it's pretty darn accurate. To see 1 millimeter in diameter, that's awesome. So yeah, I mean, overall, this was a total success, and this is going to provide great documentation for the next steps of this project. The next step of this project, I'm actually going to pull up right now. Okay, so this is the next part of this process, or at least on my part for fabricating with the Formlabs 3. As you can see, there are different things on here. Each of these columns is a part of the curing process that can be changed. Now granted, I don't have curing time on here, only just because that's a really easy thing to change, and it could affect the material, but mostly I just want to focus on these just because washing, or using the chemical wash, using water to remove any extra resin or the washing material, isopropyl alcohol to remove it, or gloss will directly affect the lenses, or at least affect them in a much greater way than what do you call it, just curing, because curing will just harden the resin. Washing, actually I've found, turns it yellowy, but actually I'll go grab an example of that. So instead of the clear, transparent stuff that I got with the lenses, you'll see it's just opaque. Now it is semi-translucent, oddly enough, if you go and look at certain spots where my oils from my fingers, because the gloves accidentally ripped, touched it. So as you can see, come on, focus. As you can see right there, right there. You can actually see that because of the fact that the oils from my fingers, because I dropped and I accidentally caught it, stopped the bath from actually removing it. So, we're going to test it with, well, here's an example of how we're going to test it. We're going to have the wash, and then no water, no ISO, and no gloss. We're just going to cure it. That's it. No water, nothing. Will this leave extra resin on there? Will it make it good? Will it make it worse? We don't know. Or we could have something where, okay, we wash it, or we don't wash it, we have water remove any extra resin, and then once the water dries, we use gloss. Which gloss is a UV curing spray gloss that apparently people will spray over their lenses to stop it from curing. It also apparently can give a better surface. Well, the thing is though, I don't know if that's true, and since we're dealing with micro optics, I don't know if it'll affect the lenses because it'll be two different forms of refraction. So, there are actually a few things that I do plan to add to this, but this was just a very basic idea. And honestly, this is going to be really great, and I can only imagine how good the table is going to look. And in the end, I'm probably going to have both my professor and some external third parties verify how good the lenses look. And by that, I just mean I'm going to show them photos without telling them what set of settings that I used, and they're gonna say this is the best or this is the worst. And ideally I'd like to have 3 to 4 different types. Now technically there should be the cure time here, but that's something that I'm gonna dial in on my own. And yeah, but this is, I don't know if this will be next week's video, but I can 100% tell you this will definitely be done in this project, just because researching the lens is really quick. Nobody is doing this stuff before. The only time you'll find this stuff where you're trying to 3D print lenses on a Formlabs printer using SLA printing is on YouTube. I mean, there's very few documented cases specifically for photon detection, which SONTRAC is trying to do. Because originally, SONTRAC is tracking neutrons in solar orbit. The problem is, you can't really detect neutron with a photomultiplier. Why? Because photomultiplier detects light. So what happens? Well, someone did a huge amount of math and determined that you can actually retrace the path of a photon when it comes into the silicon photomultiplier. So apparently, photons hit neutrons and bounces around. So that's sort of all it goes from there. But those incoming photons get put into a fiber module. I don't remember the exact type, and they actually might end up changing it. But that photon that comes out of the fiber is going to go straight into that lens, and then from that lens is going to get focused straight into that photomultiplier. And right now, currently, what happens is it comes right out of the fiber and sort of, well, not necessarily splits, but bleeds into the other lenses. And what I mean by that is there's crosstalk, or the other lenses say, oh, I see something. Meanwhile, they shouldn't. So being able to focus those lenses, or focus that photon incoming in, is perfect. Now, again, why am I talking about all this? Because nobody's doing it. Our research gap when we wrote our proposal was nobody's doing this type of stuff. And this wasn't even part of our project originally. This was, I sat in this workshop for about 45 minutes, said, I wonder if I can print something. I did, and I went, oh my God, this actually works. I showed it to my professor, and he actually said, wow, we should really look into this type of stuff. And since it's costing no money because we already have the material on hand, it's perfect. So nobody's doing this. This is an extra part to our project, and the best part about all of this, anybody can replicate it as long as they have, I don't know, $4,000. Now you might say, well, $4,000 is a lot, and it is. But that's a lot less than $1 million or $10 million. Which, funny enough, the final product that they plan to use on the module, which will be a design of our lenses requires a $500,000 extra attachment to the nanoscribe printer to do it. Because right now they can do silica, but right now they want to do silica fused glass, because glass will work a lot better. And there's a whole slew of reasons why, which I have to sort of get in my mind to fully understand them. But just starting from the basis of, can I make something on a cheap printer? I mean, it's gonna be amazing. And I know for a fact nobody's doing this. Specifically for micro optics and photons, which is absolutely amazing. Or if there are people who are doing this, then I somehow was not able to find their research. But looking up how we're going to do this just from scratch is going to be amazing, and it'll show this documentation process. And the best part is, everything will be public knowledge. So if you in 20 years come and see this video and you're looking on how I did it, you'll find out how. Or at least you'll find out in the video where I do this stuff. So if you have any suggestions on what I could do, now some people did suggest I sand the lenses, but sanding the lens is sort of an oxymoron. Why would you want to sand the lens? Because you're just gonna destroy the surface that you made? I don't know, but if you have any suggestions, please let me know, because I'm trying to figure out exactly how we can get these lenses as good as we can. Now we're gonna verify these lenses in two ways. One, we're gonna create a light focusing rig where we're going to put the lenses in one spot, we're going to put a diode in another spot, and we're gonna see what the focusing point is on that on the light that's coming out of the lens. And the second way, which I'm really looking forward to, is we are going to be using an SEM, which is a scanning electron microscope. And we're going to use that to determine the profile of the lenses. Now, the fact that I can see imperfections on my microscope means that there's going to be a lot of imperfections on the scanning electron microscope profile that we get. But again, this is a prototype, but it's a functional prototype. We're just testing to see how they will react, and it's saving us a lot of money. So, I guess to sum everything up, the lenses that we made were successful. We found out that the thin one actually printed better for some reason. It very well could be because of the support, but it printed correctly. And also, just side note, I actually can save how those supports are done, so I can just print a whole slew of them with the same support range, so that's great. But we found that the thin one printed better. We found out that as long as I don't touch all the lenses while I sneeze, they will come out nearly perfect from eyesight. Now, perfect in the way where they should be able to function. And and we found out that using the wash, not the best idea, because with the wash, you get yellowed something that you can't see through. Without the wash, you can actually see through it. I'd have to say it's sort of like scratched or just old acrylic. I guess the best way to say how see-through it is. You can definitely see through it. It just looks a little bit but it's not opaque like this stuff is. It's not even close to opaque. I'd have to say it's maybe 2% to 4% opaque compared to this, which would be like 80% opaque. And I just dropped that thing. I just shattered. But we found out that all this is gonna work and that I should continue on with this. This is going to be a great thing. I'm really excited to see, because this is a legitimate project with NASA, and being able to document something that could possibly change how NASA does something would be absolutely insane. So, if you're still watching now, thank you so much for watching. This video was more of just me documenting this process than me actually building something, so well, again, thank you so much for watching. I will see you next Sunday, 8 a.m., the usual time, and I'll let you know any updates about how these lenses are going, because they're looking really promising. Thank you.